Find the pressure at the home in pounds per square inch. In this problem, water is stored in an elevated tank with a water surface elevation of 540 feet. The elevation at the home, where the pressure is tested, is 380 feet. A 4-inch diameter pipe conveys water from the tank to the home, and various pipe appurtenances and flow parameters are also labeled. To find the pressure at the home, we'll begin with Bernoulli's equation, which states the head loss between the tank and the home equals the total head at the tank minus the total head at the home. Since the problem asks to find the pressure at the home, we'll isolate the pressure term, P sub home. Since the water tank is not pressurized, the pressure head at the tank equals 0. And since the velocity of the tank equals 0, the velocity head at the tank also equals 0. Now the equation simplifies a bit. At this point, the only unknown variable is the head loss, H sub L. The head loss is a combination of the major losses along the pipeline wall plus the minor losses caused by the fittings, valves, meters, and other appurtenances. For this version of the Hazen-Williams major head loss equation, the head loss is in feet, the length of the pipe is in feet, the velocity is in feet per second, the friction coefficient is unitless, and the diameter is in feet. For the minor head loss variables, sigma k represents the sum of the minor head loss coefficients, and the v and g variables represent the velocity and gravitational acceleration in feet per second and feet per second squared, respectively. The only unknown variables in this equation is the sum of the minor head loss coefficients, sigma k. The problem statement labels the different pipe appurtenances, and the loss coefficients for each item can be looked up in a standard table of values. The value of k equals 0.9 for the standard 90-degree elbow, 0.19 for the fully open gate valve, and 10 for the rotary meter. The quantities of each of these appurtenances is added to the table and then multiplied out. The sum of these products equals 12.37 and is used for the variable of sigma k in the minor head loss calculation. Returning to the equation for the head loss, the known variables are substituted into the equation, and the head loss between the tank and the home equals 47.6 feet. By knowing the head loss, we can return to our equation for the pressure at the home. The elevations, velocity, and head loss are plugged in and then multiplied by the unit weight of water and converted to the correct units, such that the pressure at the home equals 48.5 pounds per square inch. When reviewing the possible solutions, the answer is B.